Welcome, my friends. This is the Greek uppercase letter sigma, which is a shorthand way of writing a sum in mathematics. For example, consider the sum from n equals 1 to 4 of n. The bottom of the summation tells us where to start. The first number we need to add is the number we get when we plug in n equals 1. Then we increment by 1 and continue adding numbers together until we get to the number on top, 4. When we plug in 1 for n, we get 1. When we plug in 2, we get 2. For 3, we get 3, and for 4, we get 4. Adding everything together, we get positive 10. So the sum from n equals 1 to 4 of n is equal to 10. Consider the sum from n equals 2 to 5 of 2n plus 3. This sum tells us to start by plugging in n equals 2, and then add what we get when we plug in n equals 3, continuing to increment by 1 until we reach the number on top, 5. When we plug in 2, we get 2 times 2 plus 3. When we plug in 3, we get 2 times 3 plus 3. For 4, we get 2 times 4 plus 3, and for 5, we get 2 times 5 plus 3. Notice that the value for n in red increases by 1 for each iteration, starting at n equals 2 and increasing until we get to n equals 5. This simplifies to 7 plus 9 plus 11 plus 13, which is equal to 40. Any letter can be used as what is called the index, so you might have something like the sum from k equals 1 to 3 of k squared plus 1, which is equal to 1 squared plus 1 plus 2 squared plus 1 plus 3 squared plus 1, which is 2 plus 5 plus 10, or 17. Sometimes you will have constants inside a sum, such as the sum from n equals 1 to 6 of 4. This tells us to first plug in n equals 1. There is no n, so we just get 4. Then plug in n equals 2. Again, there is no n, so we get 4. Do this 6 times, and we get 4 plus 4 plus 4 plus 4 plus 4 plus 4, which is the same thing as 6 times 4, or 24. The sum from n equals 1 to 20 of 3 would have 20 terms, all 3's, added together, which would become 20 times 3, which is 60. In general, the sum from k equals 1 to n of c is equal to n times c. If you are adding up n constants together and the constant is not changing, the sum is just equal to the number of terms that you are adding together, n, times the constant. If you have a coefficient on one of your terms in the sum, you can pull it out. For example, if you have the sum from n equals 1 to 3 of 3n squared, there are two ways you can find the sum. The traditional way is to plug in n equals 1, 2, and 3, so that we would get 3 times 1 squared plus 3 times 2 squared plus 3 times 3 squared, which simplifies to 3 plus 12 plus 27, which is 42. But you probably noticed that each of the terms has a 3 on it, so we could factor out the 3. We would have 3 times 1 squared plus 2 squared plus 3 squared, which is the same thing as 3 times 1 plus 4 plus 9, or 3 times 14, which is also equal to 42. We could factor out the 3 from the get-go, so that we have the sum of n equals 1 to 3 of 3n squared is equal to 3 times the sum from n equals 1 to 3 of n squared. Anytime you have a coefficient on the term related to the index, it can be pulled outside of the sum to multiply it. Here's another example. Say you have the sum from k equals 1 to 4 of 5k. This could be written as 5 times the sum from k equals 1 to 4 of k, using the property that allows us to bring coefficients to the front of sums, which simplifies to 5 times 1 plus 2 plus 3 plus 4, or 5 times 10, which is equal to 50. Let's look at one more property of sums, which says that the sum of terms that have been added or subtracted can be split into two separate sums. For example, the sum from n equals 1 to 3 of 3n plus n squared can be rewritten as the sum from n equals 1 to 3 of 3n plus the sum from n equals 1 to 3 of n squared. Either way, you will get the same answer. If we evaluate the sum the first way, we have 3 times 1 plus 1 squared plus 3 times 2 plus 2 squared plus 3 times 3 plus 3 squared, which simplifies to 4 plus 10 plus 18, which is 32. If we evaluate the sum the second way, we will get 3 times 1 plus 3 times 2 plus 3 times 3, plus 1 squared plus 2 squared plus 3 squared. You should hopefully see that we have all the same terms here, so the answer is going to be the same. We still have 3 times 1 and 1 squared, we still have 3 times 2 and 2 squared, and we still have 3 times 3 and 3 squared. Simplifying, we have 18 plus 14, which again comes to 32. Let's summarize the 3 summation rules we have discussed. The sum from k equals 1 to n of c, where n is the number of terms you have in your sum, and c is a constant, is just equal to n times c. For example, the sum from k equals 1 to 7 of 4 is equal to 7 times 4, or 28. The sum from k equals 1 to n of c times f of k is equal to c times the sum from k equals 1 to n of f of k, where f of k is just some expression that has k's in it. This just tells us that a coefficient on a term that is being summed can be brought outside to multiply the sum. For example, the sum from k equals 1 to 5 of 7k is the same thing as 7 times the sum from k equals 1 to 5 of k. The last rule is that the sum from k equals 1 to n of f of k plus g of k is equal to the sum from k equals 1 to n of f of k plus the sum of k equals 1 to n of g of k, which just means that if we have two things added inside a sum, we can split them into two separate sums. For example, the sum from k equals 1 to 7 of 4k plus 2k squared is equal to the sum from k equals 1 to 7 of 4k plus the sum from k equals 1 to 7 of 2k squared. Let's look at one example that puts all of these rules together. Say we have the sum from m equals 1 to 2 of 5m minus 1 squared plus the sum from m equals 1 to 6 of 10m minus 3. For the first term, we have 5 times 1 minus 1 squared plus 5 times 2 minus 1 squared, which simplifies to 4 squared plus 9 squared, which is equal to 16 plus 81, or 97. For the second sum, we can split it into 10 times the sum from m equals 1 to 6 of m, plus the sum from m equals 1 to 6 of negative 3. The first sum is 10 times 1 plus 2 plus 3 plus 4 plus 5 plus 6, and the second sum is 6 times negative 3. We have 10 times 21 minus 18, which simplifies to 210 minus 18, or 192. So the whole thing is 97, what we got for the first sum, plus 192, which is equal to 289. Alright, my friends, that wraps up our video introducing summation notation.